students, in this video we are going to discuss about Viva question and answers for energy gap of a semiconductor diode. Before watching this video, please watch Semiconductor videos series. For better understanding of this experiment, I have given link in the description box also. Please verify it. Let us start the Viva question and answers now. Actually, for any experiment, first we should know aim apparatus and formula required for this experiment. We will also start from there only. So first, what is the aim of the experiment? So to determine the energy gap, this is important term here, to determine the energy gap of a material of PN junction diode. So this is the aim of the experiment. We are going to find energy gap, EG, energy gap of a semiconductor, right? Next, what are the apparatus required for this experiment? First one is PN junction diode. For this diode only, we are going to find energy gap, and then thermometer to measure the temperature, copper vessel where we are going to insert the diode, and then regulated power supply, and microammeter to measure the current, heater to heat the diode, and backlight lid. It should be covered over the copper vessel, and then oil, patch cords. So patch cords are nothing but connecting wires. So these are the apparatus required for this experiment. Next, formula required for this experiment. We are going to find out the energy gap. So energy gap is equal to slope into Boltzmann constant. The Boltzmann constant value I have given here, K is equal to 1.38 into 10 to the power of minus 23 joule per Kelvin. So this joule I am going to convert into electron volt, so that the value should be multiplied by 1.6 into 10 to the power of minus 19. That is charge of the electron. Okay, so that the joule should be converted into electron volt. So here the formula is 2.303 into slope into Boltzmann constant divided by 1.6 into 10 to the power of minus 19. Here slope, what is the slope here? Slope is equal to delta of natural logarithm of is divided by delta of 10 cube divided by t. This is the formula. Actually, this is the slope we will get from the graph between natural logarithm of is and the 10 cube by t. Okay, so this slope value we have to substitute. By substituting all the values of 2.303 Boltzmann constant and 1.6 into 10 to the power of minus 19, we will get the short form of the formula, that is energy gap is equal to slope of the graph divided by 5.036. Its unit is electron volt. Actually, if they are asking formula, means you have to mention this formula, 2.303 into slope into Boltzmann constant divided by 1.6 into 10 to the power of minus 19 in electron volt. Okay, so now you will have the idea about it. What is the slope? That also I mentioned here, right? Next, hereafter we are going to discuss the Viva questions from the experiment. What is diode? So first, why? Because we are going to find out the energy gap of a PN junction diode. So first we should know what is mean by diode. So diode is a semiconductor device, okay, that is essentially used for one-way switch for the current. Actually, it will act as the switch. Actually, the diode is nothing but PN junction. So this arrow mark represents P type and the line represents N. So the PN junction will act as the diode actually. So it is a PN junction is nothing but P type semiconductor and the N type semiconductors are combined together to form the diode. So it is a semiconductor device and it acts as a switch. Okay. So during forward biasing it acts as the closed switch, and during reverse biasing it acts as the open switch. Okay, that means switch on. Closed means switch on and open means switch off. Okay, so that it allows current only in one direction and it restricts in the opposite direction. This is what you have to understand. Okay, so it allows current in one direction, it restricts the current in the opposite direction, right? And diode means, already we know that diode. Okay, diode, that means what is the meaning? Two electrodes. Diode means two electrodes. One is anode and another one is cathode. So cathode means it emits the electron and anode means it attracts the electron. Okay, so this is what we have to understand. So diode is a semiconductor device. It acts like a switch. Okay, so during forward biasing the switch will be on. During reverse biasing, the switch will be off. That's what it is said. It allows current in one direction and it restricts in the opposite direction. Diode means two electrodes, anode and cathode. Cathode emits electron, anode will attract the electron. So this is the meaning for diode. Okay. So next, what is energy gap? Energy gap of a PN junction diode. So the gap between conduction band and valency band. Actually, to represent the semiconductor or conductor or insulator, we used to draw the energy band gap diagram. Here in this case, the lower energy level is EV, that is the valency band VB. I am writing valency band, and this is the EC, that is the conduction band. Conduction band. Okay, so the gap between the conduction band and the valency band is called band gap or energy gap. So in this experiment, this part only we are going to find out the gap between the conduction band and the valency band. Suppose if you are trying to make the electron to go to the valency electron, means we have to supply some energy, right? That the energy will be equal to the energy gap. How much energy we are applying to make the electrons to move from valency band to the conduction band, that energy is equal to the energy gap, right? So this is what our aim of the experiment, to find the energy gap of the given material of PN junction diode, right? Next, what is the valency band? So I said valency band and the conduction band. Actually, in all the atoms, we will have the energy levels. For example, this is the atom. So here nucleus will be in the center, and then different orbitals we will have. Okay, so the electrons will revolve around the nucleus in different orbits. So for example, in this, just one example I have taken. So here the third orbit is the last orbit. Okay, so the electrons which are present in the outermost orbit is called the valency electrons. Valency electrons. For example, the orbit itself is called valence orbit. The outermost orbit is called valence orbit. The electrons which are present in the valence orbit is called valency electrons, which are just away from the nucleus. That's what, it's a loosely packed with the nucleus, loosely binded with the nucleus. If you supply the energy, immediately the electron will jump from valency band to the conduction band, which is just above the valency band. Okay, so this is valency band and this is the conduction band. So we are talking about the valency band. So the band which possesses the valence electron is called valency band. Okay, and then the electrons which are present over here is called the valency electrons, and it is having the higher energy. See here, this is the nucleus. So this is energy level 1, energy level 2, energy level 3, like that we can mention. So the valency band will have the highest energy. Okay, the electrons which are present in the valency band will have the highest energy, right? So this is what valency band. Next one is conduction band. What is conduction band? So conduction band, just now I said valency band will be here and the valency electrons will be present over there, and then another existing band is called conduction band. So the electrons which are present in the conduction band only responsible for conducting of current, conducting of the current. Okay, so electric charge, that you have to understand clearly. If the electrons in the valency band gets energy, then immediately it will go to the conduction band. So the energy band that consists of free electrons. Here the electrons are bounded with the nucleus, but when it goes to the conduction band, it becomes free now. Okay, so the band which consists of free electrons are responsible for the conduction, I said, and those electrons are called conducting electrons. Okay, or free electrons we can say, and the free electrons present in the band is called conduction band. So electrons in the valency band getting sufficient amount of energy to move to the conduction band and contribute the conductivity. So this is conduction band. Those band which consist of the free electrons are called conduction band, which is just above the valency band, right? Next, how many types of solid materials are there? And what are those materials? Okay, what are the solid materials, types of solid materials? Actually, solid materials are classified into 3 types. Okay, so first one is conductor, and then here the next extreme is insulator. In between these two, semiconductor will be there. Okay, so solid materials are classified into 3 types. They are conductor, insulator and semiconductor, right? Next, What is conductor? So just now I said, so here conductor means it allows the flow of current charge, or otherwise allows the flow of electric current. Just now we have discussed. Example for the conductor is metals. Okay, so why it is happening? Why? Because it consists of large number of free electrons, so that when we apply the voltage, the electrons will move in one direction and the conductivity is possible in case of conductor. In that means by means of valency band and conduction band also we can explain. So this is valency band and this is the conduction band. In case of conductor, those bands will be overlapped with each other. There won't be any gap between them. Okay, so there is no energy gap here. Energy gap is equal to 0. What is here? Both the bands are overlapped with each other. So easily the electrons will go to the conduction band and the conductivity will be possible in case of conductor. So this is what we have to understand. Next, what is insulator? So as I said, insulator is the other extreme, right? So insulator means which does not conduct electricity. What is the meaning? No free electrons are there. No free electrons. What is the meaning of that? All the electrons are bounded with the nucleus. Totally bounded, tightly bounded with the nucleus. No free electrons are available for the conductivity. Okay, so an insulator is a material that has very high electrical resistance. Okay, and it does not allow the flow of current. No current in the sense resistance will be high. That's what mentioned here. There are no free electrons in the insulators. Thus, they do not conduct electricity. They are used for the protection against shock. Okay, right. Next, and here in case of energy gap, how can we explain? This is valency band and this is the conduction band. So here the gap will be very much high. The energy gap will be almost greater than 3 electron volt. Okay, so there may be very high energy gap. That's what it does not conduct any electricity. Okay, those substances which have more and more energy gap between valency band and conduction band are called insulators. Okay, why? Because it is tightly bound with the nucleus, right? So example for insulator are glass, mica, ebonite, anything we can write. Okay, next question is, what are semiconductors? Okay, so now I said solids are divided into 3 types: conductor, insulator. Both we completed. Now the semiconductor. The semiconductor is having the conductivity property between the conductor as well as insulator. Conductor as well as insulator. Actually, conductor means which conducts electricity. Insulator means which does not conduct electricity. Both are two different extremes. Okay, but the semiconductor is having both the properties. Okay, its conductivity lies between the conductor and the insulator. What is the meaning? It can allow the current or it can block the current. It has the total control. It has the total control over it. Okay, so by adding the impurities, by means of adding the impurities, its conductivity can be changed. Okay, so it will be used for different applications. Now the electrical conduction inside the semiconductor is due to electrons as well as holes. Electrons are positive, electrons are negative charge and holes are positive charge, right? So the conduction is possible due to two charges. One is electrons as well as holes. So this is what you have to understand. And then the energy gap diagram, how can I draw? Means this is valency band, this is conduction band. Here the energy gap is less than the insulator. So energy gap is less than 3 electron volt. So if you supply the energy, the electrons in the valency band goes to the conduction band. So conductivity is possible because its energy gap is less than 3 electron volt, right? So example for semiconductors are silicon and germanium. So the energy gap for this material lies between 0.5 to 1.1. For especially for germanium, its value is around 0.5 to 0.7 electron volt, right? So now you will have idea about the semiconductors. Next, what are the types of semiconductors? Okay, so there are two types of semiconductors. First one is intrinsic. Actually, these semiconductors are classified based on purity of the semiconductor, based on the purity. So intrinsic semiconductor is nothing but pure form of semiconductor, and the next one is extrinsic semiconductor. It is the impure form. Okay, one is pure, another one is impure. Pure is called intrinsic, impure is called extrinsic. So next question is, what is intrinsic semiconductor? Okay, already we said it is the pure form of semiconductors. If the temperature increases, its conductivity is also increasing. This is important. If temperature increases, okay, then conductivity is also increasing. And then here number of electrons is equal to number of holes. In the case of the semiconductor, intrinsic semiconductor, number of holes is equal to number of electrons, right? Next question. What is doping and dopant? Just now we have discussed by adding impurities. Okay, that is called doping. What is that? Pure form of semiconductor is intrinsic, I said. If you want to increase the conductivity of this intrinsic semiconductor, we have to add the impurities. Okay, so the adding of impurity is called that process is called doping process. Okay, and the material which are going to be added is called dopant. So doping means adding impurities. Dopant means which material we are going to add is called the dopant, right? So now, what do you mean by extrinsic or impure semiconductors? Okay, so impure, that means pure semiconductor, after doping it will become the impure semiconductor, which is nothing but extrinsic semiconductor. Okay, so which type of impurity we can add? Either trivalent impurity or pentavalent impurity. What is trivalent? In the outermost orbit, 3 valency electrons will be there. In pentavalent, 5 valency electrons will be present. Okay, that is called the trivalent or pentavalent impurity. Next. So now we are going to see what is p-type semiconductor and why p-type semiconductor are called acceptor impurity. Okay, let us listen. So now semiconductor, which is semiconductor I am going to consider? Silicon. Okay, it consists of 4 valency electrons in the orbit. 4 valency electrons in the orbit. So it is 4 valency electrons. With this, I am going to add trivalent impurity. What I am going to add? Trivalent impurity. What is the meaning of trivalent? 3 valency electrons in the outermost orbit. For example, aluminium I am considering. It consists of 3 atoms in the outermost orbit. Okay, so now both will make the covalent bond. One electron with this and this two and this two. Right? Here one electron is there. So here one hole will be there actually. One hole. It has to accept the electron. Okay. So this is called it. That means it provides the holes. Okay. It provides the holes for the. It is ready to accept the electron. That's what it is called, acceptor impurity. So now you will read this in a p-type semiconductor. Trivalent impurity from the third group element is added to the impurity. Trivalent impurities: aluminium, gallium, indium, boron, anything we can consider. The trivalent impurities added provide extra holes. This is important. Provide extra holes. That's what it is ready to accept the atom. That's what it is called, acceptor atom. And the majority carrier in the p-type semiconductors are holes. Why? Because here hole is there to accept the electron. It provides the holes. So holes are the majority charge carriers in p-type semiconductor. Right? Next we are going to discuss about n-type semiconductor and donor impurity. The same thing. So consider the semiconductor silicon. Here 4 valency electrons are there and I am adding the pentavalent impurities. Pentavalent. Penta means 5. So pentavalent impurities, example, arsenic, antimony, phosphorus, bismuth, etc. So bismuth, if you consider, it has 5 electrons. It has 5 electrons, right? So all 4 will make the combination, that is covalent bond. Here also we will join like that. One electron is excess. It is excess of electron, right? So here that is nothing but it donates the electron. That's what it is called, donor atom, or the impurity is donor impurity and the atom is called donor atom. So now you read this in an n-type semiconductor. Pentavalent impurity from 5th group is added to the pure semiconductor. So n-type semiconductors are formed like this. And what are the pentavalent impurities? Arsenic, antimony, bismuth, etc. The pentavalent impurity provide extra electrons. I said extra electrons. That's what it is called, donor atom. And who are the majority charge carriers in this case? Electrons are the majority charge carriers. So now you can differentiate very clearly about n-type and p-type semiconductors. Next question. Now we are coming to PN junction. So now we have clear idea about what is p-type semiconductor and what is the n-type semiconductor. When these two are combined together, it forms the junction. Okay, this is called PN junction diode. So if p-type and n-type semiconductors are combined to each other, then it is called PN junction diode. Okay, so how the p-type is formed? We have to add the third group element, and here we have to add the fifth group element. Okay, so this is called PN junction diode. So to understand the working of the PN junction diode, please watch the video. That link also I will give in the description box. Next, what is forward biasing and what is reverse biasing? Just now we have discussed PN junction. So this is P-type and this is N-type. So what is the forward biasing? P means holes are the majority charge carriers, which is nothing but positive charge, and N is having electrons are the majority charge carriers, which is negative charge. Okay, if the P-type is connected to positive terminal of the battery and the N-type is connected to negative terminal of the battery, then the connection is called forward biasing. Actually, biasing is nothing but supplying external voltage to the PN junction. Okay, supplying external voltage to the PN junction is called the biasing, in which forward biasing means P-type should be connected to positive terminal of the battery and the N-type should be connected to negative terminal of the battery. If you connect like this, the current flow will be there in this circuit. So for better understanding, please watch that video for forward and reverse biasing connection for PN junction. That link also I will give in the description box. Next, reverse biasing. So what is the reverse biasing? It should be opposite to forward biasing. So P-type, N-type. This is positive charge, this is negative charge. So P-type should be connected to negative terminal of the battery and the N-type should be connected to positive terminal of the battery. So this is called the reverse biasing. If you give like that, the current flow will not be there. There won't be any current flow. So that is called the reverse biasing. But due to minority charge carriers, very important, due to minority charge carriers, okay, very small amount of current which is in the order of microampere, that is 10 power minus 6 ampere, the current flow will be there in the circuit due to the minority charge carriers. For that reason, that current only responsible, that current is called reverse saturation current. The reverse saturation current is related to the energy gap. Okay, so our aim of the experiment is to find the energy gap. So for this experiment, we are going to use the reverse biasing and we are going to find out the reverse saturation current to determine the energy gap of the experiment. Okay, so in this bias, the current is mainly due to minority charge carrier, very small amount of current which is in the order of microampere. So this is very important. For this experiment, which biasing is given means immediately you should answer reverse biasing. Okay, so almost all the all the topics which are related to this experiment I discussed in this. If you have any doubt regarding this, you can ask me in the comment box. Thank you everyone.